In this last lesson of chapter 10 that we're going to do, I know this is a really short chapter, is we're going to look at radical equations. So a radical equation is an equation that contains a radical expression with a variable in the radicand. So we're looking for variables underneath the radical sign. To solve a radical equation involving a square root, first you're going to use properties of equality to isolate the radical on one side. Then you're going to eliminate the radical. So basically, that's a long way of saying you're doing GEMDAS backwards. Okay. We're trying to isolate the variable by getting first the radical alone, and then we're going to do the inverse of the radical. There's an important property that you have to understand in order to do these equations, and it's down here. If two expressions are equal, then their squares are equal. So if a equals b, then a squared equals b squared, because mathematically, as you know, if you do something to both sides of the equation, then it's still balanced, right? Like if you subtract 5 from one side, in order to keep it balanced, you have to subtract 5 on the other. So if we square both sides, our equation is still equal. So here's why that's important. In example 1, we want to get the value of x. So just like we would normally do, right, you would hopefully say, well, I think I can subtract 5. So you get radical x equals 8. Now, the core concept right up above says if I square both sides, my equation is still balanced. So those cancel out, and you just get x equals 64. Whoa, that's it? Yes, that's it. It gets a little trickier, but just play along. So I'm going to subtract 3. So I get negative radical x equals negative 3. Divide both sides by negative 1. So radical x equals 3. And then you square both sides, and you get x equals 9. That's it. What? That's it? Yes, that's it. Sometimes they look more complicated, but they're really not. So, if you think about GEMDAS backwards, we're going to first get rid of the addition. Then we're going to divide by 4. And then you square both sides. So x is equal to 14. That's it. It can get trickier when there's radicals on both sides. This is a newbie style question, so it's not really as complicated as it can get. But there's really nothing to move to another side. We have the radicals isolated on each side of the equation. So I'm at the step where I can just square both sides. So I get 2x minus 1 equals x plus 4. Now I have a variable on both sides, so let's just drop a line and let's subtract x. So you get x minus 1 equals 4. Add 1, and you get x equals 5. Okay, so there we go. It is very similar with cubes and cube roots, so it's the same kind of idea, but now instead of squaring both sides, we're going to cube both sides. So I don't have to do anything, I don't have to move anything to another side. I'm at the step where I can just cube. Oh, I have no idea what 12 cubed is. Luckily, I've got my calculator nearby. It's 1,728. So obviously you add 2. You get 5x equals 1,730. Divide by 5. And I don't know what that is. 346. All right. Now, I told you it gets a little more complicated. Here's where it gets a little more complicated. Sometimes you have these things called extraneous solutions. And in a square root equation or a cube root equation, or what we could just call a radical equation, sometimes the math will tell you that there's an answer, but when you go back and you check it, it doesn't work. So with radical equations, it's really important that you check. If you don't check, you're going to get caught because you're going to end up with what we called an extraneous solution, meaning a solution that the math tells us works but actually doesn't. Here's how that works. So according to this equation, I'm at the step where I can just square both sides. So you get x squared equals, those cancel out, so you just get x plus 6. Back in chapter 9, I taught you to move everything over to the left. So you get x squared minus x minus 6 equals 0. I think I can factor that. So I'll get x minus 3, x plus 2. So the values that I think work are 3 and negative 2. Now let's go back to the equation and let's check it. So I'm going to check 3. So we get 3 equals the square root of 3 plus 6. So 3 equals the square root of 9. The square root of 9 is 3, so that works, right? Okay, now let's check negative 2. So I have negative 2 equals the square root of negative 2 plus 6. So now my next step would say negative 2 equals the square root of 4. But I told you that when you're given the symbol, it's either the positive or the negative. So this is actually only 2. If they wanted the negative answer, they would write negative radical 4, which they did not. So this is what we call extraneous, because negative 2 does not actually work. The math told me it did, but then when I plugged it in, it didn't. So the only solution is x equals 3, and we would reject this. All right, let's check out another one. And as you can tell from the title of the example, we're going to find an extraneous solution. So first thing I'm going to do is subtract 13. So I get radical 5n equals negative 10. Now I square both sides. So we get 5n equals 100. So that gives me that n is 20. So let's go back and check it. So let's check. 13 plus the square root of 5 times 20 equals 3. So that's 13 plus the square root of 100. But that's not true, right? Because the square root of 100 is 10. And obviously 23 does not equal 3. So 20 doesn't work. So we reject it. But then since there's no other number to say as the answer, right? Like in the last question, we had 2 answers, so one of them worked and one of them didn't. This one, the only number that we got didn't work. So what we say, since that answer got rejected, is that there's no solution. Because the math wants there to be a solution, but when we checked it, sadly, it didn't work. All right, example 7 we'll save. If you have any questions, write them down and ask me when you talk to me next.